New Year! Happy New Year from all the kids in Mrs. Lehman's class. This is Math with Mrs. Lehman, and I'm Mrs. Lehman. I'm here in my 6th period class. They are super anxious to do our first video of the new year because we're going to try to get 100 subscribers. So please don't forget to like and subscribe. Anyway, I think we're up to like 70-ish. Alright, so you guys had homework that I'm going to collect here in a little bit. And you had this bell ringer. It says, write an inequality for the following numbers, 2, 8, 7.5, and hint the number monster. So, we have a key word here, inequality. Alright? Who knows what the prefix in means? Blaze? No, very good. So, not equal, essentially, is what this word means. So we're not going to have an equation, we're going to have an inequality, meaning it has a less than or greater than symbol in there instead of an equal sign, okay? So when you guys were in probably 1st grade, we little math students, you guys learned about the number monster, and you probably had a very kind 1st grade teacher that said, 1 is less than 2, right? And you guys said, oh, that's the number alligator or the number monster. And you may or may not have drawn teeth in there. All right. Now you're in 6th grade, though, so we have to slap a fancy label on it now. Instead of calling it the number alligator officially, we are going to call it an inequality. And we are going to leave the teeth out of the number alligator. And instead of just doing 2 numbers, comparing 2 numbers, we're going to actually start comparing 3 numbers a lot of times. And the numbers aren't going to be whole numbers, which we now know are called integers, right? We're going to use some other rational numbers like decimals and fractions, and some may even be negative numbers. So there isn't a whole lot more to it. It's just the numbers look a little different sometimes, and we may have 3 numbers instead of 2, okay? And no teeth. Well, you have your teeth, but you know what I mean. All right, so what's the first step when I have these 3 numbers? What do I need to do with them? What do I need to do? Victoria?
Write them down on their paper.
Okay, in
Least to greatest.
order from least to greatest. You could do greatest to least. It doesn't really matter, but in this case, we'll just do least to greatest. So what's the smallest number here, everyone? 2. Okay, what's our next biggest?
7.5.
7.5, and our largest is 8. Okay. So, what symbol do I need to put in between here? Cam.
Greater than?
So you're saying 2 is greater than 7.5.
I mean,
If you're
less than.
Are you sure?
Yes.
Your final answer is?
Less than.
Yep, you're correct. All right, so 2 is less than 7.5, which is less than 8. All right? Raise your hand if you had that on your paper. Pat yourselves on the back. Nice job, guys. Did anyone choose to list them from greatest to least? Oh, okay, that's why Cam said that backwards, because on her paper, she did it this way. All right, so Cam, how would you read this? So 8 is, which is, there you go. So that explains that confusion. All right, nice job. So again, put them in order from least to greatest. You should not have numbers pointing at each other. Did anyone do this? Did anyone do that? That's wrong. Do not do that. Right? All of your points should be pointing in the same direction. All the mouths, the alligator mouth, should be open in the same direction. All right? Moving forward, what is the prime factorization of 36? So first of all, if we know we are going to do prime factorization, you need to know what a factor is. What is a factor? Brianna?
A factor is a factor is a number that is. Oh, a factor. Oh, I don't know why I thought you said factor. Okay, a factor is a multiple of a number.
Nope, it's not a multiple of a number, but it's numbers that you can
Multiplied by.
multiply to get a
Multiply to get a number.
bigger number called a
Product.
product. Very good. All right. So we need to think of numbers that we can multiply to get 36. Those would be factors of 36. So we have a few different options here. So everybody in your head think it's something that multiplies to get 36, okay? We're avoiding in prime factorization ones, all right? Because every number has a factor of 1. So we're looking for anything besides that, all right? Eden.
6 and 6.
6 times 6. Who else picked 6 times 6? All right? We could have done some other ones. What are some other ones we could have done? Cam?
3 times 12.
There you go.
9 times 4.
Very good. 2 times 18. There you go. That's all of them, I think. All right, so now you have to do that whole thing where you decide, is this a prime number or is this a composite number? So again, you need to know what a prime number is and what a composite number is. Who can tell me what a prime number is? Malaya.
3.
3 is an example of a prime number. Why do we consider 3 prime, Aiden?
Because it can only be multiplied by 1 itself.
Not multiplied, the only factors.
Yes.
All right, so say that again.
The only factors are 1 in itself.
Very good. So if a number only has 2 factors, one which is 1 and the other itself, then it's a prime number. So you can't break that down any further. If it's composite, we can. So composite numbers have multiple factors other than just 1 in itself. So 6, is that prime or composite?
Composite.
Final answer, everybody.
Composite.
Composite, because we can break that down. All right, what times what would give us 6? Malaya?
3 times 3.
That's 3 plus 3. We're looking for things we multiply. 2 times 3. Yep, very good. So we need to make sure we're multiplying here. Right, Jonathan? All right. So, he's nodding his head. All right, so 2 times 3. Guess what? We can break up this number the same way because it's the same number. Huh? All right, so is 2 prime or composite, everyone? Prime. Circle it. That means we can't touch that. All right, and 3, prime or composite, everyone?
Prime.
Very good. 2?
Prime.
3?
Prime.
You got it. All right, so we're not done yet. What is the prime factorization of 36? What do I need to do underneath this? Riley? Very good. So we're going to put them in order, least to greatest. So 2, and we're multiplying them. So 2 times 2 times 3 times 3. And if we did this correctly, we'd have 2 times 2 is 4, 3 times 3 is 9, so 4 times 9 is 36. So if you did it correctly, these are all prime numbers at the bottom, and it multiplies to give you your original number. All right? I'm going to pause this to explain something from the homework. So in case anyone was wondering, I was able to collect the papers in 12 seconds. Yep, 12 seconds. Ooh, yeah. All right. And I didn't fall on my head or anything. Okay. That you know of. All right, anyway, we're on lesson 11 today. So if you guys could all turn to page 42 in your books, please. It's been a while. These kids have forgotten everything. They have math amnesia. Math amnesia. They forgot everything. All right, anyway, we're on page 42-ish, or 42 exactly. Lesson 11. So, again, we're going to put some real fancy words on some things that are really quite simple. So, absolute value simply means distance from 0 on a number line. All right? So, absolute value, we're going to write distance from 0 on a number line. So you'll see absolute value, find the absolute value. That just means how far is this number from 0 when it's on a number line. And magnitude means the same exact thing. So you may see a question that asks about the magnitude of something, and that's really just asking for you to give the absolute value of that thing. Sometimes you might see the word impact, perhaps, but maybe impact we could add here as synonyms for absolute value. Okay? So they're interchangeable. I don't know what you'll see or which word you'll see, but you'll see one of them eventually. All right? All right, so this opening exercise. Everybody, touch your toes. No, I don't know what the exercise is here. This is a number line, kids. All right, so who can tell me a number that's on that number line? First of all, what is the scale of that number line? It's jumping by ones, right? All right, so it's a scale of 1. Who can give me a number that's on that number line? Christoph?
-10.
-10. All right, pick another one just because we're going to use -10 so much. It's going to make you sick to your stomach.
-5.
-5, okay. -5 is right here. Who can tell me how far away that is from 0? Just what's the distance? Riley?
5.
5 away, right? So you just found the absolute value of -5. How do you write absolute value? Well, they're blah. I cannot talk. So anyway, you make sure that they don't look like ones. They're not parentheses, they're not brackets, they're just 2 straight parallel lines. They're slightly longer than the number. Make sure it doesn't look like 1 minus 51, okay? You got to make sure that these look like, well, it looks like absolute value. Anyway, so the absolute value of -5, the distance from 0 is 5. So that started as a negative number, right? We found the absolute value of a negative number, and it all of a sudden transformed into a positive number. All right. Example 1 here. It says the absolute value of 10 is written as absolute value of 10. On the number line, count the number of units from 10 to 0. So we're going from here to here. How far is this distance? 10. Very good, Brianna. 10. All right, so we would say the absolute value of 10 is 10. Yep, that's how difficult this is, kids. All right, so here's a real trick question. What other number has an absolute value or a distance from 0 of 10? What other number is 10 away from 0?
-10.
Very good. So we would say the absolute value of -10 equals, what was that again? 10. Very good. So whether it started as a positive number or a negative number, absolute values are always going to be expressed as positive. Very good, Caleb. Positive. All right? So, because we're just saying how far away it is from 0. All right, so why don't we put a big star next to this statement, and who would like to read that nice and loud for our YouTube viewers? Michael.
The absolute value of a number is the distance between the number and 0 on the number line.
Very good, thank you. All right, so that's what we said before. It's just the distance from 0. All right, here's your math joke of the day. I know you've been waiting in suspense, but you guys ready? Okay, now remember, sometimes numbers are expressed as letters. They're called variables, right? It just means an unknown number, one that we don't know. All right, here we go. It says blood bank. Here is the phlebotomist or doctor, maybe. It says, that's impossible. I can't have a negative blood type. So, when you have the absolute value of a number, the outcome of that can never be negative, right? So he or she's arguing, that's impossible. I can't have a negative blood type. This is going over some people's heads, but some people just aren't laughing because it's not that funny. But it's pretty funny. Thank you to I did not draw this. I stole it from the internet. Snodgrass. Okay, well thank you, Snodgrass. We're moving on. Okay, here's a handy dandy chart. It is on page 43. Wow, the next page. All right, so complete the following chart. We have the number, and then we have to give its absolute value. So if we have -6, right, here's 0. Here's, wow, that's really blurry. There's -6. How far of a jump is that? O'Reilly.
6.
So the absolute value of negative 6 is 6. Yep, positive 6. All right, so we know this has a distance of 6. What other number besides negative 6 would also have a distance of 6? Brianna? Positive 6. Very good. So negative 6 and positive 6 both share the same absolute value of 6. All right, number 2 here, it says 8. What is the absolute value of 8? Everybody?
Positive 8.
Oh, I'm hearing all kinds of things.
Positive 8.
Positive 8. Will we ever have a negative absolute value? No. So from 0, let's see, to 8, that's a distance of 8, right? So its absolute value is 8. What other number will also have an absolute value of 8? Emma knows.
Negative 8.
Very good, Emma, negative 8. All right, are you noticing a pattern here? All right, negative 1, what is the absolute value? What is the distance? What is the magnitude of negative 1? 1, yeah. What other number besides negative 1 has an absolute value of 1? Cam?
1.
Very good, 1. All right, do you guys notice anything special here? Could we determine a rule from this? Jacob? I have no idea what this kid's going to say, but let's hope for the best. Everybody, cross your fingers.
If a number is negative, its absolute value will always come out positive.
That is true. That is true. Now, we know negative 6 and 6 are considered what? Opposites. So what can we say about opposites in absolute value? A number and its opposite will always
Be the opposite.
Be negative. Be
Sorry, gotta come up to Michael.
A negative number and its opposite will always have the same absolute value.
So any number and its opposite, right, will have the same absolute value. Very good. So let's see. Let's write this down. Right under here, a number and its opposite will have the same absolute value. Now, some kids earlier today made the mistake of saying they had the same value. Well, I know $8 and negative 8 do not have the same value, but they do have the same absolute value. All right, so please be careful in making sure you know the difference. All right, so yes. I'm going to pause this. Mrs. Owens received a call from her bank because she had a checkbook balance of negative $45. Way to go, Mrs. Owens. All right. You probably got the same sale at Target that I did. Okay, so anyway, we're talking about negative $45. That's how much she owes. That's how much her debt is. All right, what is the absolute value of negative? What is the magnitude of that negative 45? Aiden?
45.
Yep, very good. Told you guys this was a tough lesson. Really tough. All right, so again, this is restating that the magnitude of a quantity is found by taking the absolute value of its numerical part. So you look at the number and you take the absolute value, okay? Magnitude and absolute value mean the same thing. All right, let's move on. After you put some beautiful stars there. Congratulations. All right. So for each scenario below, we use absolute value to determine the magnitude of each quantity. So this is a wonderful visual. Thank you, New York State. It says Maria was sick with the flu and her weight change as a result of it is represented by negative 4 pounds. All right. So we want to find the absolute value of negative 4. Now again, make sure it doesn't look like 1 minus 41 on your paper. Make those a little bit longer. All right, absolute value of negative 4. What was the magnitude of her weight change?
4.
4, very good. All right, you guys are getting the hang of this. Let's go on to the next page. Jeffrey owes his friend $5. So how much are we? Oh, for you guys it's not the next page. For me it's the next page. Whatever, we're on number 5, okay? Wherever that is for you. Jeffrey owes his friend $5. So if you owe money, is that positive or negative? Negative. So -5, absolute value of -5. What's the magnitude of that debt? 5. Very good. 5. All right. Number 6 and 7, I'm going to give you about 30 seconds to do on your own. Again, I want you to put what it's talking about and then what the magnitude of that is. Okay? So I'm going to pause this for about 30 seconds and let's see if we can get the right answers. Okay. So number 6 says the elevation of Niagara Falls, which is located between Lake Erie and Lake Ontario, is 326 feet. How far is this above sea level? So we are talking about 326 feet. What is the magnitude of that? Eeny, meeny, miny, bam.
326.
326, very good. All right, the next one says, how far below zero is -16 degrees Celsius? I don't like the way that one looks. Brianna?
16.
16, very good. So again, these always come out positive. Scrolling down, I'm skipping that one just because I feel like it's regurgitating stuff. All right, Meg is playing a card game with her friend Iona. The cards have positive and negative numbers printed on them, and Meg exclaims, because she loves to brag, the absolute value of the number on my card equals 8. So the absolute value of her card equals 8. That's not an 11. That's absolute value. What card could that be in there? What card could it be, Michael?
-8.
-8. Could it be another card? 8, I heard. Yes. Could it also be 8? You betcha. All right. Number 10. List a positive and negative number whose absolute value is greater than 3. So the number we put in here has to be greater than 8. Wow, I'm making up my own problems. Sometimes my brain and my smartboard writing hands start doing 2 different things. So what number could we put in there, Riley?
1,822.
There's always got to be that kid, and today Riley's trying to be that kid. What number was that again?
1,822.
I'll play your game. Okay. Hold on. Let me get some space here to write that big number. What was it again? 1,000. Leave it to Riley. All right, you're right. The absolute value of that is greater than 3. All right, because the absolute value of this... Oh, wait. Did you say 23? 22. Oh, I did it right. Okay. So the absolute value of that is this, and that is indeed greater than 3. Now I need someone else, hopefully not being that kid. I'm just picking on you, Riley. All right, what other number that's negative? I'm hesitant right now. Joey. He's got this grin. He's up to no good. What are you going to pick, Joey?
-2.
Oh. Well, that's incorrect because what's the absolute value of -2? 2. Is 2 greater than 3? No, so pick a different number that's actually bigger than 3.
-8.
-8. Oh, I accused you of being that kid, and you weren't even that kid. It's just these innocent-looking ones like Riley that pull that stuff. All right, not that you don't look innocent, Joey, but you know what I'm saying. He had this smirk on his face like he was going to do that. So -8, he said. Right? When we take the absolute value of -8, what do we get, everybody? 8. And 8 is greater than 3. So this is saying the same exact thing. Okay? Any questions on this? All right, let's move forward on to, which could be your next page. I don't know. I've lost all track. This question I don't really love. What else is new? Which of the following situations can be represented by the absolute value of 10? Yeah, you know what I'm going to do? I'm just going to have you guys find the absolute value of these. So what is the absolute value of 10 degrees below 0? So -10, right? The absolute value of that is is, no, not negative 10, it's just 10, right? So that negative 10 by itself does not have an absolute value. It does not equal 10. I don't know. We're just going to do it this way. Determine the size of Harold's debt if he owes $10. So, again, owing money means negative 10. Absolute value of that, we're talking about $10. Blah, blah, blah. Let's go on to number 12. All right. Number 12, it says Julia used absolute value to find the distance between 0 and 6 on a number line. Oh, distance between 0 and a number. She was finding what? Hey, Aiden, you want to say that again?
Absolute value.
Oh, he changed his tone. Before he said absolute value. All right. So anyway, it says, then she wrote a similar statement to represent the distance between 0 and negative 6. Below is her work. So we're going to play teacher here. All right. And we're going to figure out if she's correct. So her first statement here is the absolute value of 6 equals 6. Do you think she is correct?
No. Yes. Yes, she is correct. Yes, she is correct.
What's it? Tori, tell me, what's the distance from 6 and 0? So is she correct in that one? She's correct in that one. So this one is correct. Way to go. All right. The next one, it says the absolute value of negative 6, or the distance from negative 6 and 0, she's saying is negative 6. Is she correct? Yes or no?
No.
No. Garbage answer, Julia. All right, so the absolute value of negative 6 should be 6. Again, they always come out positive. All right, number 13 asks us to use absolute value to represent the amount in dollars of a $238.25 profit. So profit is positive or negative? Positive. All right. So what's the absolute value of that? Bless you.
238.
Very good. It's the same thing, right? All right. Judy lost 15 pounds. What's with all this weight loss? All right. Judy lost 15 pounds. So are we talking about a positive or negative here? Negative. So negative 15. What's the absolute value of negative 15?
15.
Positive 15. Yep. Oh boy, we have Carl and Angela getting into a heated debate about integers and absolute value. Aren't you glad you're not in their class? Just kidding. Sounds wonderful, doesn't it?
Yeah.
Sure. All right. Carl said two integers. Listen carefully. Two integers, so two positive or negative numbers, can have the same absolute value. All right. So can two numbers have the same absolute value? Yes, right? Positive 5 has an absolute value of 5. Negative 5 has an absolute value of. All right, so we know what he's saying. Angela says that one integer can have two absolute values. Can a number have two different absolute values? No. So who do we want to agree with? Carl. Carl is right. Angela is left. Angela is incorrect. All right, so Carl is correct or right, and then we can defend this by saying the absolute value of negative 5 equals 5. There's the absolute value of one integer. Here's the absolute value of another integer that happens to have the same absolute value, therefore proving Carl's point. So any number, again, and its opposite are going to have the same absolute value. All right? Okay, I'm going to explain your homework. So if you guys could flip to page 47. Woo. Okay, so questions 1 through 4, you have to decide which of these two numbers has the greater magnitude. Magnitude is a synonym for what again?
Absolute value.
Absolute value, very good. So they want you to compare the absolute value of the numbers they gave you. $33 compared to the absolute value of negative $52. All right, so let's rewrite this without the absolute value stuff going on. So what's the absolute value of 33? 33, right? What's the absolute value of negative 52? 52. Which one's bigger? 52, right? So we're going to do this. So for 1 through 4, that's what I would like you to do. All right? Does that make sense? Write them as inequalities, like that example. Let's move on to problems 5 through 7. Through 5 through 7, you have to answer which one is true and which ones are true and false. If it's false, you need to explain why it's false. Okay? So once you read those, you'll see. And then number 8 and 9, you get to be the module maker. I'm sure you'll do a better job. All right, write a word problem whose solution is not negative, the absolute value of 20 equals 20. So again, be using the words magnitude, impact, what is the absolute value, those types of things, okay? And then for the last question, you have to determine which has the greatest impact on the account balance. So if you withdraw $60, or you withdraw, I should say, $60, you have a withdrawal of $60, what would that be represented as? Negative, right? So negative 60. What is the impact of that on the account? That changes your account how much? $60, right? The next one, it says a deposit. Remember, depositive. That's positive or negative? Positive, yep. So absolute value of $55 is 55. I'll let you do the last one, but you have to determine which of those has the greatest or the biggest magnitude or impact on the account balance. Okay? Yes. A withdrawal is negative. Anyway, it is time for us to end class. I'd like to thank you for watching. Please don't forget to like and subscribe. Have a great day. Bye.